Welcome back to another Daishinfinity video. In this video, we're going to talk about the derivative of the inverse sine function. So let's dive right in and prove this formula in the first place. Before we start proving this derivative of the inverse sine function, we would have to define the limit definition of a derivative. So the limit definition of any function f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So since we have this function f of x, we're just going to plug in the inverse sine of f of x inside the function. So what we're going to have is the limit as h approaches 0 of the inverse sine of x plus h minus the inverse sine of x all over h. Now, since we have this one, we have a difference between two inverse sine functions. And especially, we have a property that states that the inverse sine of A minus the inverse sine of B states that it is the inverse tangent of A minus B. So let's write the A over here. A minus B all over the square root. So this one is going to be a big denominator, 1 minus a square, the whole thing times 1 minus b square, and plus ab. So this is the formula for the difference between two inverse sine functions. So let's just plug in the x plus h for the a and the x for the b. So we would just get the inverse tangent of x plus h minus x, the whole thing over the square root of 1 minus x plus h squared times 1 minus x squared plus x plus h times x. Now the x's will cancel out, so we are just left with h over the whole thing. So since we have the limit, we're just going to plug everything inside the limit. So we would have the limit as h approaches 0 of the inverse tangent of h over the whole gibberish thing all over h. Now I would like to let this whole complex mathematical expression equal to some constant or some variable eta. So if we let eta equal to this one, then we have to see what will happen with eta when h approaches 0. So if h approaches 0, the whole thing will approach 0, so eta will also approach 0. So we can indeed say that we have the limit as eta approaches 0 of inverse tangent of eta, the whole thing divided by h. Now, we know through a fact that if we have any coordinate system and we have this function called inverse tangent, then the asymptotic line of the inverse tangent on the y-axis is equal at pi over 2. But since we want eta to go to 0, when eta approaches 0, this one will also approach 0, and the function eta will also approach 0. So we have a 0 over 0 situation. So we have to take, for example, if we would have the limit as eta approaches 0 of the inverse tangent of eta divided by eta, we can take the derivative on both sides of the fraction. Since we have the L'Hopital's rule, we can use this as the limit as eta approaches 0 of 1 over eta squared plus 1 times 1. So this one will approach 0, and 1 over 1 will give you 1. So this whole thing will give you 1. And since 1 will really simplify the limit, we would want to have inverse tangent of eta over eta. How can we do it? So let's go back to the original limit. The original limit is the limit as h approaches 0, or let's say eta approaches 0, since we have eta right now, of the inverse tangent of eta divided by h. But we can do something. We can multiply the eta here. So we have the inverse tangent of eta divided by eta. But since we divided, we have to also multiply on the top side. So now we can split the whole thing up through the limit rules. So we have the limit as eta approaches 0 of inverse tangent of eta over eta, and times the limit as, let's use h here, because eta goes at 0, h also can go 0. So we can use h here. So we would have here the h eta over h. Now, inverse tangent of eta divided by eta will also approach 1. So we have 1 times something, so it's just something. So we are left with the something, which is the limit as h approaches 0 of eta. But what is eta? It is equal to h over the whole gibberish thing. So 1 minus x plus h square, and then again 1 minus x square plus x plus h times x, and then divided by h. So this h will cancel out with the h we have, let's say, here. So it will cancel out here and here. So we are just left with the limit of this whole fraction. So let's write it down. It's just 1 over the whole thing. So we would have 1 minus x plus h square times 1 minus x square plus x plus h times x. Now let's just let h approach 0. If h approaches 0, this would approach 1 minus x square here. And if this one approaches 0, this one will equal to x square. So this would equal to the fact that we have the limit of that one, and which will equal to 1 over the square root of 1 minus x square. So since we just proven the derivative of the inverse sine, we just proven the derivative of this function. So I hope you understand why the derivative is something like this, and we'll definitely see us in the next Daishinfinity video. See ya.